Okay, for our next problem, we're going to compute the surface area of the portion of z equals 13 minus 4x squared minus 4y squared above z equals 1, where both z and y are negative, or non-positive. So you can pause and take a look at that. So this is one of our favorite functions, actually. This is a quadric surface that we care about. So this over here, this is a paraboloid. And it's downward facing. I think it's easy to see that if you put this surface in, cylindrical coordinates, where it is z equals 13 minus 4r squared. And so in the z r plane, you go up here to 13, there's some intercept, and then that's a downward facing parabola. And so if you spin this around, you get a paraboloid that's downward facing. What we care about is the portion of this that is above z equals 1. So we're only going to care about this bit up here after we spin it around. And then we're also further restricting it to be where x is negative and y is negative. So that's the portion that's above the third quadrant, if I can count my quadrants correctly. And so we're just taking a quarter of this overall surface area. So we could just compute the total surface area of this portion of the paraboloid and then divide it by 4. That would be one way to do this problem. But we could also set up the integral to only integrate over the portion that we care about. Personally, I think I'm going to do it by just computing the whole surface area of the surface and then dividing it by 4. But what you should think is that what I'm saying is we are basically just computing the surface area of like one of these quarters in this drawing of this paraboloid and not the other quarters. So not the back, not the right and left, right? So, but I'll just do that by dividing by 4. So we're going to integrate over the whole disk. Yeah. Cool. So let's figure out how to compute this. So the way I would do this problem is I would set up z equals to 1. I would set that equal to 13. I would plug z equals 1 into 13 minus 4r squared, because I basically want to figure out in this paraboloid what is the base of it, this disk that I want to integrate over, that's parallel to the xy plane, but it's in z equals 1, which is a plane 1 up from the xy plane. So I basically want to understand what's this, when you spin it around, this little cross-section here gives you, which is this, gives you this whole disk. And so I want to understand how big that is, what the radius is, so that I can compute the right radius for the disk. So let's solve for r. So if I put 4 r squared on this side, I get 12 when I subtract 1 over to that side. So r squared is equal to 3, which means that r is the square root of 3. And we're just going to make a note. We are going to throw out minus the square root of 3 because r needs to be a positive radius. And the negative radius is kind of already factored into the positive radius points in polar coordinates, or in cylindrical coordinates. So now we already were given the formula for the surface, and I already converted it to polar. So So I think my final surface area that I want is a quarter of what I would get. Let's draw a better 4. A quarter of what I would get for the surface area over the disk, radius square root of 3, of this function. So 1 plus fx, so this is f up here, squared plus fy squared dA. So fx and fy are both easy to compute. From that formula, it's going to be minus 8x, and fy is minus 8y. So, scrolling down, my integral is the square root of 1 plus 8 times 8 is 64, so 64 x squared plus y squared dA. And I'm just going to immediately turn that into polar coordinates. So that's a fourth. Theta goes from 0 to 2 pi. R goes from 0 to radical 3, because that's our disk. The square root of 1 plus 64r squared, r dr d theta. And I think that's also where I'm just going to stop the problem, because from here on out, it looks like I can do some easy u sub to integrate r, and then all of the terms have constant bounds. So we're basically done. So looks to me like u should be 1 plus 64r squared. So du is 128 r dr, which means that my final answer should be 1/4 1 over 128. And then when I integrate square root of u, I get uu, so 1 plus 64r squared to the 3 halves times 2/3. That looks good. And I'm evaluating r from 0 to radical 3. And then I'm multiplying that by theta, which I evaluate from 0 to 2 pi, which just gives me another times 2 pi. And so to finish it out, we've got what? If I can combine like this 2 and the 4, let's see, I get like a half times 128th. That's 256th times a third. And then when I evaluate this at 3, I'm going to get 64 times, or is that radical 3, I'm going to get 64 times 3, whatever that is, plus 1. So I'm just going to write that as 1 plus 64 times 3 to the 3 halves. Great. Minus, at 0 I get 1 to the 3 halves, so that's 1. And then times 2 pi minus 0. And that's a good answer right there. And I also think that's a good place to end the lecture for today. So have fun. Bye.